Okay, thank you everyone. My name is Li Li. It sounds like a girl. From Peking University, China. Today I'm present our work multi-label test categorization with heating components. Okay, in our work we aim to capture hypercomponents which will represent the inner structure of labels. We aim to incorporate these hidden components into multi-label test categorization. This is our outline. Okay, now let me introduce what is multi-label test categorization. In traditional test categorization, a document is only assigned with categories. But in multi-label test categorization, a document can be assigned with multiple categories. Here is an example. A newspaper article confirming global warming can be classified into categories: environment and science. So, if a reader interested in the environment, I think we should I should display this news to this reader. And if a reader interested in science, I think we should display this news to the reader too. Okay, the key point of multi-label categorization is a correlation among labels. For example, a political document is likely to be an economical document, but if a political document is likely not to be a literature document. So if we can use this correlation among labels, we will improve the performance. How to use the correlations? According to the latent value model, we get the correlated labels result into some hidden components which represent the inner structure of the labels we use it. Okay, let's ignore this PDF. Ignore this PPT. Let me introduce our methodology. Our method is consistent of 2 steps. Step 1, to contain the hidden components. And step 2, we incorporate the hidden components into the joint learning framework. In step 1, I think this step is very simple and straightforward. We employed PCA on a label set to obtain the hidden components because the PCA is very popular and powerful. Okay, now we use the logistical regulation to build our model for the multi-label test categorization. So the prediction function is the formulation 1, and the C is the code obtained by the linear transformation X, as shown in the formulation 2. In our following optimization, we will enforce the code close to the hidden components. This is the way how we incorporate the hidden components into the multi-label test classification. So now as the machine learning problem, we have 3 goals. First one, to fit the training data. Second, to control the complexity of the model. And third, to enforce the code close to the hidden components. To achieve these three goals, we use the following optimization objective function, like this. Okay, let me explain this objective function detailly. The first term is the loss function of logistical regression. Minimize the first term is to fit the training data. The second term is I think is very popular. The L2, the non-true regularization. Now, the point of our work is the third term, which minimizes the third term. We can enforce the code close to the hypercontainers. Remember, the code is the linear transformation of the document X. So the final objective function is like this. Now we have two parts of parameters, the W and M. We use the alternative optimization to optimize the W and the M. Okay, this is all about our methodology. Now we introduce our experiments. First, let me talk the evaluation metrics. First one is Hamming loss. The lower is better. The HX means the predicted label vector, and Y is the true label vector. Their symmetric difference is the Hamming loss. Zero and one loss, how to say? If there is any difference between the predicted label vector and the true label vector, we get one error. F score, I think is very common and popular. Data set we use three multi-label data set in this table. N denotes the number of the training instance, and D denotes the number of the features, and M denotes the number of the labels. Okay, we compare two baselines in our experiments. The baseline one, this baseline elements the PCA, so which just adds an equatorial set of nonlinear features. To implement this baseline, I only need to set the lambda 2 is to 0. The lambda 2 parameter is the coefficient of the third term in the objective function. To set it is to 0, we only have two goals. The baseline 2 eliminates the joint learning framework. I think it's very simple. This baseline completes the hypercomponents with PCA, train a linear model to fit the components, and use the outputs of the word as features. Okay, this is a result. This is the result, or this is the performance comparison in terms of three environment metrics. Okay, our proposed method win a little. We also compare our method to to other methods, binary relevance is very simple. It trains a classifier to each label. The second method, classifier chain, is also train a classifier to each label too, but the output from the formal classifier is used as the feature as the formal classifiers. The third method uses employ the example method, and the fourth method use the improved KNN as the best classifier in multi-label classification. Okay, this is a performance comparison in high-min loss. Is a performance in terms of 0-1 loss. Okay, the last performance comparison. Conclusion: we propose to capture the hypercontinuance of the labels and incorporate LANG into the joint learning framework for multi-label test classification, and experiments show the effectiveness of our method. Okay, the future work. Indeed, our work is in progress. So you see, you can see the way of obtaining hypercontinuance is very simple and straightforward. So in the future work, we will employ or develop a way of obtain hypercomponents. Maybe we can employ a topical model of water vector. Okay, anyway. Okay, thank you all.
Okay, is there any question? I have one question. Considering, would be interesting probably to apply your approach to, for instance, tweets in Twitter, considering each hashtag as a label in order to find the correlation between the labels, the hashtags that are being used.
You mean use the hashtag in Twitter as the labels and
yes.
Twitter as the
in order to, I mean,
document.
Yeah, seeing if there is a certain correlation among the way, I mean, the way users use, I mean, hashtags.
Okay. Indeed, we did not use any data set. So maybe we will change the data set to the one which is also foremost multi-label data set, which is much bigger, and now try to find the application of this of the multi-label classification of our math. So maybe you will be into Twitter and hashtag as label will be interesting problem. We will try to solve.
There are questions? Because Lily was very fast, so we have plenty of time for questions.
I think I can answer your question because I'm one of the authors. You mean that you use hashtag as labels and use Twitters as instance, right? And there may be multi tags for Twitter. In fact, this kind of data is perfect for this tags. And in Twitter, there's a lot of tags, like millions of tags, and this method is very suitable for efficient decoding of which tag you should take. So I think yeah, because the characteristic of this algorithm is a fast decoding of the many labels. Yeah. So I think this data set is very competitive with this algorithm.
So if there are no further questions, we thank the speaker again.